everyone. So let's get a move on with today's class so that you can break off earlier. Okay, so on Monday we stopped here. Did you manage to find all the partial difference? Did you manage to find all the partial differentiations along with the higher ones? Okay, someone give me the answer. Just give me the answer. Then you those of you who haven't done it, you can just double check against the answer once you start doing it. Okay, so mana sudah? X sine squared y. Where is x sine squared y? Oh, here. Okay. Okay, so the first one. Wait, come on, share with me. What's the square? F. No, we do. Sorry, we do the partial first. D F dx. What's df dx?
Sin 2y.
Sin 2y or sin squared y?
Sin squared y.
Yeah. And then anything else? Because the other
That's
side
it.
is y and x. So there must be something you need to differentiate because there's a cos x there. The other side, so you leave y as constant, you differentiate cos x, right? What do you get when you differentiate cos x?
Oh, I've overlooked it.
Differentiate cos x, what do you get? Negative?
Negative sign.
Yeah. So negative sine x, and then the y squared is constant. Okay? So that's the answer. Okay. So from there, you can proceed to find d squared f dx squared. You can also proceed to look for d squared f dy dx. Are you able to do this? But you know what to do, right? It's exactly the same process as what we've done during class. Okay, give me the x squared. I won't bother. Give me the bottom one. D squared f dy dx. What's the answer? Anyone? Wait, who has done it? Can I get the answer, please? Someone, quickly. The faster you give me the answer, the faster we can move on, and then we can end the class. It's still a lot of materials to go through, man. We still have a lot of materials to go through, man. Quick. What's the answer for this one? Come on.
2 sin y cos y negative sin x 2y.
Okay, good. Thank you. Sepat, who is that?
Me.
Yeah, what's your name? I cannot see my Google Meet screen.
Atalarik Firmansyah.
Okay. Okay, thank you. Okay, yeah, ngam. Betul? Okay. So good, thank you. Next, The other one, you guys can work it out on your own. Okay, I'm not gonna bother. Okay, so you know the process. Okay, so is there anyone who cannot do this, or you don't understand anything? You ask me now. Are there anyone who can't do this? You can ask me now. Or you all know how to do this, no problem.
Yes, we know.
You know, okay, all right. Okay, then you can work out the rest on your own. So df dy, you can work this out on your own. And then d squared f dy squared, you can work this out and work that out on your own. And then d squared f dx dy, you can work this out on your own. Yeah. Okay. So then I'm not gonna bother. Okay, I'm going to continue. Okay, with the rest of the lecture. Okay. So what else do we want to go through today? Let me see. Okay. So far, we've done partial, we've done higher derivatives, but we've done 2D. Well, partial, we've done 3D now, okay? But for higher, we've done 2D. So what happens when you go to things like, when you go even higher, okay? When you go, let's say 3D. So when you go higher, basically this is what you get, okay? So you may get X, Y, and Z now. So previously you only have Y and Z. So this is the same like partial. Yeah, partial we can do X and Y. We can do X, Y, Z. Okay. So now when we get to the higher derivatives, same thing. We can do X and Y as well, which is what we've done earlier. Or we can go X, Y, Z. We can go one variable higher. Okay. So let's tackle one example here. So let's say I have this function here consisting of x, y, and z. So x squared y cubed minus y squared z cubed. Find. Okay, so this one I'm gonna word it, the question I'm gonna word it a bit different. If you don't understand, you ask me. Find x, y, z. Find f, y, z, x. Find f, z, y, x, and then find x, y, x. Okay. So these things, you know what I mean? Do you know what they mean?
No, doctor.
Okay. So basically what I mean is actually so what these are they are simplification, a simplified way of writing this. D cube f dz dy dx. Okay, it's a simplified way of writing this. Okay, so okay, so let me give you a simple example. When I give you a function like that, okay, when I give you a function like that, and I ask you to do df dx, the answer is 2x lah. Okay, I can also write it this way. That means you differentiate against x. That's what it means. Okay. And I can also go one higher. df squared. Yeah, this one you've seen before, guys. That means, so if you see something like this, we've done this before on Monday. This means you differentiate against x first, then you differentiate against y. Remember, you do this one first, you do this one second. Yeah, so you differentiate against x first, and then you differentiate against y. But if you write in terms of f saja, then you will write x, y. So it's a bit confusing, huh? So what it means then is you differentiate x first, you differentiate y second. So these two operations are actually the same thing, but the way they are written is different. You pay attention to this, huh? Okay, faham gak sekarang? Yeah. So the answer is 2x, and this answer, if you differentiate against y, there's no y, so it becomes 0 lah. Any faham gak? Do you understand?
Understand.
Okay. All right. Anyone doesn't understand, you need me to repeat again?
Sorry, doctor, but I didn't understand.
Okay, that's fine. Yeah. If you don't understand, you have to let me know. Okay, let me explain one more time. Okay, let me explain one more time. No problem. Okay, so normally the questions, so normally when I give you a function, I give you a function like this. Well, let's a single one. I may give you a function like this. Okay. When I ask you to differentiate this, I can write it like this. df dx. That means you have to differentiate, correct? This one, do you understand, Hussein?
Yes, I can.
Okay, that's fine. So, however, there is actually another way. I can write this, which is fx without the bracket. So you see, no brackets. Yeah, this one has no brackets. They both mean the same thing. So when I write fx like this, what I'm telling you to do is you differentiate against x. It means the same. It means differentiate against x. If I write it like this, do you understand this, Hussein?
Yes.
Yeah, this one means you differentiate against x first, and then the next step and then the following step you differentiate against y. This one you understand, right?
Yes.
Okay. Now, an alternative way of writing this is I can also write it like this: f x y without the brackets. What this means is the same. It means the same thing. It means I want you to differentiate against x first and then differentiate against y later. Okay? This means differentiate as well. The only thing you have to pay attention is if you look at the order, this I want you to pay attention to this. Let me use another color. Wait. Green. Okay. The only thing you have to pay attention is this and that.
Okay.
If I do df over dx dy, that means the first variable that you differentiate against is the one on the right, and then you differentiate against this. But if I write it in terms of f xy, the first term is actually the one on the left, and then the second term is actually the one on the right. It's reverse. Do you notice?
Yes.
Yeah. So you have to be careful. This is the only thing you have to be careful. Huh? Okay. All right. Okay. Is that okay, Hussein?
Yes. Okay. Thank you.
Okay, no problem. All right. Okay, good. So make sure you guys copy this down now. Okay. Yeah. One more thing before I forget. I'm supposed to make an announcement. Yeah, KP asked us all to make an announcement. You probably, if you attended a class yesterday, maybe another lecturer has already told you about this. Yeah. So what was it about? Okay. Yeah. So recently, so this is an announcement, nothing to do with calculus, nothing to do with calculus. So I don't know whether you've heard, recently there was a couple who was caught doing something. I don't know what you call it. Something X-rated. Yeah, something X-rated on UMS premises. Did you hear about this?
No.
No? Okay. Okay. Well, now you have. Okay. Now you have. So there was a couple, a boy and a girl. They were caught doing something naughty in a car. Okay, so they were caught by the security keselamatan lah. Yeah, they were caught by keselamatan because the car was shaking heavily. Yeah, I don't know. Yeah, the car was
Okay.
shaking heavily. So maybe cowgirl or something in the car. Okay, so the message is, hope. Well, they are not from our faculty, luckily. Okay, so that couple apparently is not from our faculty. So I don't know from which faculty. So, but at least not from FKJ. So that's at least that's a bit of good news. So the advice is, don't do something like that in UMS premises. Okay, because if you get caught, it will affect our faculty's good standing. Okay. So if you want to do something like that, you go outside of UMS. Okay, so that's the announcement I need to make. All right. So don't do anything like that inside UMS premises. Yeah. Boys and girls. Okay, so let's continue with our lecture. Yeah. So okay, let's continue with this example then. Okay, so now I've given you this function. Okay, given you this function. So now I want you to look for the higher derivative, but this is actually much higher. This is like 3 times you. Yeah. So if you look at this, basically all of this. Basically, what it wants you to do is it wants you to differentiate. It looks funny, but it's actually very simple. Basically, what it's telling you to do is it's telling you to differentiate. Yeah, differentiate 3 times basically. Okay, differentiate 3 times. So the first one I've written down for you. The second one is this x dz dy. Yeah, if you see, pay attention to this. X, Y, Z, and then at the bottom is Z, Y, X. Yeah, it's always reverse. Y, Z, X, X, Z, Y. Yeah. I'm gonna just write it all. I'm gonna just write it all out for you, so that it's clear. Okay. So this is this, and finally this is this. So what does it? So what does it mean? So what this means is, for the first one, basically what I want you to do is, I want you to do df dx and then do df dy, and then finally do df dz. Okay, this one I want you to do df dy, df dz, and then df dx. Yeah, so the rest you know lah. I don't have to write up. Okay. So you understand, Yan, what's happening?
Yes.
Okay. Good. So let's tackle the first one. So f x y z. Okay. So f x y z. So when I write it in this format, that means you do x first, you do y second, you do z finally. Okay. So let's differentiate this thing here. Here. So differentiate this against x. So when you differentiate against x, everything else becomes constant. Okay. So actually only one side has x. Yeah, only the first term has x squared. You differentiate, so y cube is constant. So you just write y cube, you don't touch it. X squared, you differentiate, what do you get?
2x.
Correct. Very good. Thank you. 2x. And then the second term, y squared z cube, it's all constant. Y is constant, z is constant. So what happens when you constant?
0.
0. Yeah. So the answer for this one, well, actually we should yeah, sorry. We need to do step by step. So you asked it to do f x y z. Okay. I cannot write it like this. Wait. Okay. So we do x first. So fx first. So when I do fx, it's whatever just now that we did. Yeah. It's y cube times 2x minus 0. Yeah? This is what we did just now. Okay. So it's 2xy cube. Okay. So 2xy cube is the answer. Okay. So next step, we've only done fx. Now we have to do fxy. Fxy. So fxy means you are now dealing with y. Yeah. Fx we've done already. Now we have to do y. So what happens when you differentiate y? So x becomes constant. So 2x is constant. We just write it down. Times differentiate y cube, you get 3y squared. So equals to 6xy squared. Okay. Next, f x y z. Now we are doing the z term. So we do the z term. X is constant, y is constant. So actually this whole thing is constant. The whole thing is constant. You differentiate this constant against z, what do you get?
Same value for xy.
Well, we are differentiating against z. So this one is constant. So if you differentiate, what do you get?
0.
Correct, 0. Yeah, you get 0. You understand? Do you guys know why we get 0? Yeah, because we are differentiating against z now. There's no z in here. Yeah, so y. If y equals to 2, I ask you to differentiate dy dx. What is the answer? Because we only have a constant. We don't have an x here anymore. Becomes 0, right? So same thing here. This whole thing is a constant. We don't have z in there anymore, but we're differentiating against z. That's why we end up with a 0. Okay. Okay, good. Okay, so do I have to do the rest? It's straightforward, right?
Yes.
Yeah, the rest is straightforward. I give you the answer. You do on your own. I will give you the answer. I'll give you the answer now. You do it on your own. Make sure you know how to do it. Okay. So the next one was f y z x. Okay. So you have to do df dy first, and then you do df dz, and then you do df dx. Okay. But eventually the answer you're gonna get 0 as well. Okay. Next is this, also 0. Next is this, you should get 6y squared. Okay, so these are all the answers. Do it on your own. Okay, do this remaining 3 on your own, please. Please. Okay. Right. Let's go on to the next. So if there are no questions about this, we will go on to the next
Sorry,
exam.
doctor.
Yes.
Can you just explain the first one, F, Y, Z, X?
Yep, sure. You want me to go through?
Yeah, only F, Y, Z, X.
Okay,
Because I
yeah,
didn't get
sure.
Y, Z.
Yep. Okay. So f, y, z, x means you have to do fy first. You're differentiating against y. So when you differentiate against y, so here. So we go back here. Differentiate against y. So if you differentiate, so let's look at the first term first. Yeah, so we look at this one first. If we differentiate this against y, that means x squared is a constant. So you just copy down x squared. Okay, and then the y cube, differentiate y cube, what do you get? 2,
3y square.
2y squared. Oh, sorry, 3. Yeah, correct, 3. Yeah, right. 3y squared. Yep. Minus. So the next term is y squared z cube. So we are still differentiating against y. So z cube is a constant. So we're going to just write it down. Z cube is a constant. So y squared. Yeah. So y squared differentiate, what do you get? 2y, correct?
Yes.
Yep. Okay. So 2y. So your answer is 3x squared y squared minus 2y z cubed. Okay, so this is the first answer. This is the first answer. Now the second is f y z. Okay, so now we are differentiating against z. So the first term here, there's no z at all. If you everything's constant. So if you differentiate against z, what do you think you're gonna get?
0.
Yeah, 0. Correct. Okay. Minus 2 is a constant. Y also a constant. We are differentiating the z only. So when we differentiate z, what do you get? 3z squared. Agree?
Yes.
So the answer is negative 6yz squared. Okay. And finally, to get the final answer, f y z x. So now we are differentiating against x. Are there any x in there?
No.
Everything is a constant.
Yeah.
That's why it's 0.
Okay.
Yeah.
Okay, thank you.
Okay, all right, no problem. Okay. What about other people? I want to hear other people's voice as well.
Good.
Everyone else.
Understand, doctor.
Okay.
Faham.
Faham, huh? Okay. Faham. That's good if you understand. Okay. I don't want you to message me at 11 o'clock at night later before final exam and start asking me about all this. Okay. If you want to ask anything, you ask now. Okay. So if you understand, we do another example. Okay, we do another example. This one a bit. Is this coming up in the final exam? If it's not, then maybe no need to do. Maybe we can skip. Let's do it. Let's do it. Okay, so this one I'm gonna go through with you lah. This one's not very easy. Okay, so now we have this function. I'm not gonna use f. I use h here, but it means the same thing. It means the same thing. Okay, so I have a function here, which is inverse of tangent y over x. Okay, so this looks a bit scary. I'm scared as well actually, but we try to do it together. Okay. Okay. What is inverse of tangent? So what I want you to do here is I want you to find all second partials. Do you know what this means? Second partials. So everything we've done up to this point is actually partial derivatives. Okay. So first partial is when you differentiate one time. So in this case, how many variables do we have? X and Y, right? We have two variables, right?
Yes.
Yeah. So first partials are dh dx dh dy. Yeah. So you can see here what are first partial. First partial means you differentiate one time. Yeah, basically that's what it means. First partial you differentiate one time. Okay, you differentiate once. So we only have two variables here, x and y. So you can only differentiate against x once and differentiate against y another time. So only two. If you have three variables, x, y, z, then you're gonna have three of them. Okay. But in this case, we only have two variables. So our first partial, there's only two of them. Okay, dh and dy, dh dx and dh dy. Okay, so those are first partial, differentiate one time. Now, second partials, can you guess what I mean? How many times?
2 times.
Correct. Second partial means you differentiate two times. So again, you have to do the three. You have to do the three thing. So from dh dx, you can do dh d squared h dx squared. You can also do d squared h dy dx. Yeah. So what this means is you differentiate against x two times. What the second one means is you differentiate x first and then you differentiate y. Yeah. So the same with dh dy. With dh dy, you can do d squared h dy squared. That means you differentiate y two times, or you can do d squared h dx dy. This means you differentiate against y first, and then you differentiate against x. Okay, so those are all the possible second partials. No more. I can't think of any more. Okay, so those are all the second partials. All right. So in my question, So in the question, what did I ask for?
Find second partial.
Yeah, so the question is correct. Find all second partials. So what that means is you need to look. I want to use different color. So what that means is I want you to look for all this second partial. I want to find all this. But to find all this, you have to find that this both as well, lah. But they won't count towards the marks. Okay. I want you to look for all this. But to look for this, you also have to look for the first partial as well, lah. Okay. Are you able to do? So you know what to do, right? You know what to do, right?
You mean for the first partial?
Correct. You need to start off with the first partial. Okay. So actually this question is simple. Okay. You do dh dx and then you find your second partial. You do dh dy and then you find the second partial. The difficult part of this question is what? It's actually this, the differentiation part. Okay, the calculus one. This is calculus one. How do you differentiate? How do you differentiate inverse of tangent? This is the difficult part. For me, it's also the difficult part. How do you differentiate inverse of tangent? Now, this is actually not calculus 2. This is from calculus 1. From calculus 1, do you still know how to differentiate this? Inverse of tangent, y over x. How do you do it? How do you differentiate inverse of tangent? What is inverse of tangent? What is inverse of tangent? Anyone wants to offer an explanation? What is the inverse of tangent?
I need to refer to the table first.
Okay, it's okay. Yeah. Well, I'll let you know. You can double check later. Okay. So inverse of tangent. Okay, I'm not gonna do the difficult one, y over x. I'm gonna just tell you the simple one first. Inverse of tangent x is actually arctan x. Have you seen arctan x before?
No.
Okay. Inverse of tangent is basically the same as arctan. Arctan. Okay. So when you differentiate, inverse of tangent x, you are actually differentiating also inverse of arctan x. Okay. What do you get when you differentiate inverse of arctan x? You basically get 1 over 1 plus x squared. Can you check on Google now? Quickly on your computer or on your mobile phones. Check on Google to see whether this is correct or not. So that you know I'm not lying to you.
Yes, doctor. Based on Google, it's the same.
Yeah. Okay. So this is correct. Okay. Okay. So that's the relationship. Okay. Inverse of tan x is also the same as arctan(x). And when you differentiate arctan(x), you get 1 over 1 plus x squared. Okay, so now that we know this, let's solve this thing. So to get the second partials, you need to do your first partial. So you need to do first partial. So your first partial means your no squared df dx, or I can write it simply hx lah if I want to. Okay, it means the same thing. Okay, so what do you think it is hx? Differentiate. So you differentiate this. Now you're differentiating this. You're differentiating this thing against x. So y is constant. So y is constant. How do you differentiate this? Okay, so imagine. So think of it like this. Okay, so think of it like this. So what you're trying to differentiate now is you're trying to differentiate tangent, what inverse of tangent? Y over x, right?
Yes.
Yeah. But y is a constant. Y is a constant, huh? So y is a number. So I'm gonna just put a number here. For now, 1 over x. So that it's clear. So that you know it's a constant. So that it doesn't confuse you. I'm gonna just replace my y with 1 right now, so that you know it's a constant. So that it doesn't confuse you. So how do you relate the one on top with the one below? So the one on top, it's inverse of tangent x, but we are doing inverse of tangent 1 over x. How do we do this? Well, it's the same. Yeah. So at the top, it's inverse of tangent x. What we want to do is inverse of tangent 1 over x. Our 1 is actually y, but I put 1 in there lah, just to make sure it's constant. Okay, or better I put y. I will just put the correct one in there. Put y. But this y is constant. This y is a number. Okay, this y is a number. So what do you think? It's the same. You just copy exactly what you have done. So you know the answer is this: 1 over 1 plus x squared. So it's 1 over 1 plus y over x squared. Agree? You just copy the exact same thing now. Yeah, you see? X. Well, sorry. X squared. Y over x squared. Do you see that?
Yes.
Okay.
Yes.
But it's finished yet. It's not finished yet. It's actually not as simple. Okay? It's actually not as simple. Okay? There's something else you have to do. What else do you have to do?
Differentiate.
Yeah, you have to differentiate what? What do you have to differentiate?
X.
What do you have to differentiate? There's something you have to do for that number inside there. Well, what do you think it is? You actually have to times the term, this term. You have to times this term. You have to times the d over dx of that term inside y over x, which will give you 1 over 1 plus y over x squared times what? How do you differentiate? Okay, let's take this out. Let's take this out. Do it separately. How do you differentiate? How do you differentiate this? How do you differentiate this? How do you differentiate y over x when y is a constant? So you bring you y times. Okay, wait. So you can rewrite this in terms of d over dx. Y. You can bring the x up, so it becomes like that, right? To differentiate x. Agree?
Yes.
So when you differentiate it, it becomes negative yx minus 2. Agree?
Yes.
Agree.
So then it becomes negative y over x squared. Agree?
I agree.
Yeah. So now you put your answer back here. Negative y over x squared. So now you multiply everything together. Is that okay?
Okay.
So this is the first partial only. At the moment, we only found this. We only found the first partial. So it's what? So this one multiply together, so you get negative y over Jesus. I multiply my x in there. Multiply in there. So we get x squared plus blah blah blah. X cancel out. Y squared. Yeah, that's what we get. Yeah. So next. So this is first partial only. This is the first partial only. This first partial. Now we have to look for the second partial, which is d squared f dx squared, and also we have d squared f dy dx. Okay. So for these two, I want you to work it out on your own. Okay. Basically, for this one, you basically differentiate this against x one more time. For this one, you differentiate this term against y. Okay. So do it on your own. Find all of this. This thing. Find all this. Okay. I've only done this for you. I've only done the red one, this one. I've only done this for you. You have to do this, and this. Okay, well, this as well, so that you can look for the other two. Okay, do this on your own. Could be a test question, you never know.
So, Doctor, but can you just help us to do dh over dy, or just show us how?
What, this one?
Yeah, this one.
Okay, yeah, sure. Okay, so I will look for. So I will help you look for all the first partials. Okay, all the first partial. So the other first partial is dh over dy. Okay, so this is the other first partial. Okay, so dh over dy. So you are differentiating against y. Yeah, so you're differentiating against y. So let me just write the formula down again so that it's clear. Okay. So that we don't have to keep going back up to the top of the page. Okay, so this is what we're doing. I'm just rewriting the question. I'm just rewriting the question so that we don't have to keep going back up to refer to the question again. So this is the question. Okay, so now we are doing y, dh over dy, or I can write hy. Okay, so now we are doing the other first partial, differentiating against y. So when you're differentiating against y, so yeah, not z, this is x. Sorry, z, x. Okay, so when you're differentiating against y, x becomes constant. So think of this like this. Inverse of tangent y over, I don't know, y over 2 or something. Okay, x is now constant, it's a number. So you think like it's 2 or 8 or 10 or 1000 or something like that. It's a number now. Okay, so we know, you know that inverse of 10x is this, 1 over 1 plus x squared. Yeah. So if it's this, what do you think it's it? What do you think it is? Well, it's 1 over 1 plus y over 2
Square.
squared. Yeah. But you always have to times the differentiate of this as well, the one inside. That term inside, you always have to differentiate it again. Yeah, times the differential of the thing inside. So it's 1 over 1 plus y squared divided by 4 times. Oh, sorry. It's actually not 2 lah. It's actually x. It's actually x. I just asked you to assume it's 2 so that it's easier to imagine what's happening. Yeah, it's a number. So it's x squared lah. Okay. Okay, and then times d over dy, y over x. Okay, that's what you're doing. So if x is a number, you just have to differentiate y. Yeah, we're differentiating against y now. What do you get when you differentiate against y? This is y to the power 1. What do you get? The y goes missing, right? When you have, okay, when y is x over 2, dy dx, what do you get? What's the answer? Don't think about the left hand side. Just look at this. When y is x over 2, dy dx is what? You can take the half out and leave the x. So you just differentiate x. You differentiate x, what do you get?
1.
1. You end up with 1, right? X becomes 1, right?
Yes.
Yeah. So you end up with answer of half, correct?
Yes.
Okay, good. So now we go back to our question. It's the same thing. X is now a constant. So you are differentiating x is now a constant. So you are actually differentiating, you think of it like this. 1 over x times y. This 1 over x is actually a number. So you are just differentiating y. If you differentiate y to the power 1, what do you get?
1.
1. Times. So the 1 over x you have to keep. It's a constant. y you differentiate, you get 1. So that's what you get. Times 1 over x. That's what you get. Okay. How do you simplify this a little bit? So this is a bit complicated. So this one, once you get here, if you have to differentiate against, if you have to do the higher order differentiation, the second partial, this is very difficult to do. You need to simplify this. How do you simplify this?
Multiply 1 over x with the other one.
But you multiply 1 over x, it's very messy, right?
Yes.
Or what you can do. So this 1 over x, is actually multiplied. Yeah, it's actually multiplied. So actually it goes on top here. It goes on top here. Okay, you can write it like this. Okay, so what you can do actually is you multiply with the biggest denominator. The biggest denominator is x squared. So you multiply the top with x squared, you multiply the bottom with x squared. You see what I'm doing? So what you then get is this cancels out. This becomes 1 power. This and that cancels out. So you're left with this. You have to multiply by x squared. So you end up with this plus this. Now, this is easier to work with. You understand how I got from there to there?
Yeah, it's all clear.
Yeah. So basically what I did, let me use a different color. Let me use a different color. So what I did was x squared. It is x squared. This is squared. Okay. This is x. So what I did was then I introduced x squared over x squared. I'll multiply this in there. I multiply this in there. I multiply this in there. That's basically what I did. Okay, so now I found the first partials. So now I found this. I found this. I want you to look for this. Okay? Maybe a test question. So make sure you know how to do this. Any questions? Anyone?
No, for me, all clear.
Okay. Good. What about everyone else? Why is everyone else so quiet?
Good.
Good, ah? Okay. If you're happy, then I'm happy. All right. Okay, so what do we want to do next, huh? Is this coming out in the test? This one not coming out. Don't worry. So maybe we jump to give me a second. Let me see what else I want to teach you. Can you just focus the ones that may come out in the test? The differentials. What is this? Chain rule. Do you need to study chain rule? Do you know what is the chain rule? You're gonna get so confused if I teach you this. We do another one first, lah. We do a simple example first. We don't do the chain rule. Otherwise, your brain is gonna explode. Okay, let's do something simple. We do the new topic chain rule later next week. Okay, I was going to go into chain rule right now, but yeah, you may get confused. So that's why I don't want to do it. I'll continue with the example. Okay. See how considerate I am. Okay, so we do one example and then we finish the class. All right. Okay, so right. One last example. The surface area of a cat, let's say, in meters squared per kilo is approximated by this formula. Okay, S equals to 0.007 184 W to the power 0.425 times HH 0.725. Okay. Nah, maybe not cat lah. Maybe I don't know. Maybe human. Okay. So the surface area of a human in meters squared per kilogram is approximated by this formula here. So what that means is, as a human, okay, so as a human, your skin, yeah. So as a human, your skin has an area, yeah. So if I kill you, I take off your skin, there is a specific amount of skin area that I can take and sell to the shops. Okay, so this surface area of skin is related, has a relationship with your body weight. Yeah, so m squared is your skin area. Yeah, m squared is your skin area. Kilogram is your body weight. Yeah, so as your body weight increase, technically your skin area also goes up, correct? Fat people has more skin, right? Do you agree?
Agree.
The fatter you are, the more skin you have. Okay, so weight is related to skin area. Okay, so weight is normally measured in kilogram. Area is normally in meter squared or square feet lah. But in this case, I'm using meter squared. Okay, so the relationship is given by roughly by this formula here. I don't know who came up with it. I don't know whether it's correct or not. But never mind. We're doing maths here, so it doesn't really matter whether it's correct or not. Okay, but that's the relationship. Okay, so the question is this. Okay, so this formula, what it does is it relates S surface area with W weight and also height. Okay, it relates all these three things. Okay, So the question is this. What grows faster? Oh, sorry. What grows the skin faster? So how do you get more skin, basically? What makes your skin grow faster? For a person weighing 70 kilograms with a height of 180 cm. Okay. So there's a person weighing. So there's a person who has a height of 180 cm and a weight and a body weight of 70 kilograms. Okay. If I want to increase his skin area, do I need to make him taller or do I have to make him heavier? So what grows the skin faster? Weight or height? Yeah. So if I want him to have more skin, do I need him to increase the weight or do I want him to become taller, basically? Strange question, huh? Okay. So so how do you do this? Anyone?
To be honest, no idea, Doctor.
Huh?
I have
No
no
idea.
idea.
Okay. Okay, so to answer this question, we can investigate two options. Okay, we can investigate two options. So this example here is an example which we can apply what we learned earlier, our partial derivative. So we can apply partial derivative to solve this problem. Okay. Okay, so if you are a serial murderer and you kill people to sell their skin, then this problem will be very helpful to you because you can see how you can maximize the skin that you can sell. All right. So apply partial derivative to solve this problem. So how exactly do you solve this problem? So we have two variables here. We have two variables. One is the weight, one is the height. Okay. We want to see which one of these is more contributes more. Which one of these contributes more to the skin growth? The weight or the height? Okay. So what we can do is first we keep the height or the h constant. We change the weight. Now do you start to see how this is very similar to what we're doing? H constant, W is variable now. So that means you take this formula. You take this formula, you what? You keep H as a constant, you differentiate W, correct?
Yes.
Okay, so we take that formula. So S, so the formula is S. So what you want to do is you want to do DS. DS, D, we want to change W. So we want to change weight, so it's W, which is the variable. and H is constant. H is constant. So let's rewrite the formula. Otherwise, very difficult to differentiate. Someone tell me the formula again. 0.0 what?
7184 W power of 0.425.
Okay, and then
H power of 0.725.
all right. Okay, great. Okay, so if we keep H constant, we change weight. That means it's ds dw. Okay, H is constant. Okay, so that means 0.007184 is constant. H also constant. We just differentiate this. Okay, so what do you get when you differentiate this? How do you differentiate this?
0.425.
Wait, let me copy this down. Okay, yeah. 0.425 W.
W minus 0.425.
0 point? Well, it's 0.425 minus 1, right?
Yeah.
So it's 0.5. 575. Do you get it, Jose?
Yes.
Yeah, it's 0.425 minus 1, which is negative 0.575. Yeah. Okay. So that's the answer. Okay. So that's the answer. Now, next, what you do is we know our H is we know our W. What is the weight of that guy just now? 70 kilograms, right? In the question.
Yes.
70 kilograms, height 180. Yeah. So weight 70 kilograms, height 180. Can you substitute this in? Oh, what happened? Wait. Something happened. Okay. Okay, sorry, yeah, let me restart again. I don't know, crashed. My app crashed just now. Okay, so weight 70 kilograms, height 180. Can you substitute 70? Can you substitute W into W? H into H? Give me give me a number. So 70 0.007184. H is 180. So 180 to the power 0.725 times 0.425 times W to the power negative W is 70. So to the power negative 0.575. Yeah. 180. Can you calculate for me? What is the number? What answer did you get?
0.011359.
Yeah, correct. 0.011. Yeah.
Yeah.
Okay. So this is in m squared per kilogram. Yeah. So as I said here, that the unit is m squared per kilogram. Yeah. So this is in m squared per kilogram. Okay. So this is one option. This is one option that we do. We keep the height constant. We change the weight. Now, next, we keep the weight. This is option one. This is option one. Okay. We've done option one. This is our answer. Now, let's do another option. Now we keep the weight constant. We change height. We keep weight constant now, we change height. So 0.007184 W 0.425 H 0.025. Okay, so now if I want to keep weight constant, we change the height. That means ds d what?
H.
H, correct. Yeah. So now you keep W constant, you differentiate against H only. Yeah. So it's 0.00. Wait. (0.007184). W is constant. So you dWdH this. So what's the answer? So what do you get when you differentiate this? You copy down 0.725 H, and then 0.725 minus 1 is what? Negative?
0.275.
Yeah. Very good. Thank you. Okay. So that. So again, we know W is 70 kilograms. H is 180. Can you substitute this in there? Substitute that in there. What's the answer?
Doctor, I have a question.
Yeah.
The height is given in cm, right? Should we convert it to meter first?
Yeah. You can convert it to meter. You can convert it to meter. Yeah, correct. Because you are right. Because the answer is in meter. Yeah. You can convert it to meter. Yeah, you should convert it to meter. So if it's meter, then 1.8. Yeah, then 1.8. So you have to divide. Yeah, divide by whatever. But it doesn't really matter. In the end, the answer is still comparable. If you use 1.8 there, then you use 1.8 here. Okay. Okay, can you repeat the answer? If it's 1.8. Okay, let's do the number 2 first. If it's 1.8, what's the answer?
(0.007).
Okay. This is in cm, right? Correct?
Yes.
Yeah. Okay, never mind. No need to convert. We just change this to cm cube, then okay already. Okay, no need to convert. We keep it at 180 cm. Yeah, you just change it to cm cube. You just change it to cm cube, then okay already. Okay, so now we have the two answers. When I change weight, which is the first one, when I change weight, the skin area will change by 0.011. Area change by 0.011. When I change height, area change by 0.0076. Okay, so what is the question just now? If I want to make the skin grow faster, do I want to change the weight or to change the height to get an area change bigger? Which area change is bigger? Weight or height?
Wait.
Yeah. That gives you a bigger change in area, the weight. So what does that mean? That means if you want to grow more skin, you increase your weight rather than height. That's what it means. Okay. If you want to grow more skin, you increase your weight, you can increase your skin faster than if you increase your height. Okay. Any questions?
For me, all clear.
Okay, thank you, Sen. Everyone else?
Okay, okay.
Okay.
No, doctor.
No questions, huh?
No.
Okay. So lah. So I think we conclude our class for today. Monday, you cannot do afternoon, right? You are busy in the afternoon, right?
Yes,
Yes.
doctor.
Okay. No choice lah. Okay. Then we will have our test at 8:30. Okay. So Monday berapa hari bulan, ah? 17, 18, 19, 20, 20.
Doctor.
Yeah.
This is on the dot product and cross product, right?
Correct.
Okay.
Yes.
Nice.
Correct. Yeah. So Monday test, we start at 8:30 lah in case traffic jam. Yeah. On dot and cross product. Vectors in general lah. Okay. You need to know how to convert coordinates to vectors. And then you need to know how to do dot product. You need to know how to do cross product as well. Okay. And maybe you need to know how to find unit vectors. You need to know how to convert from coordinates to vectors. You need to know how to find magnitude. Things like that. Okay.
Okay.
Okay, one question only. One question. I will probably give you 45 minutes to do it. Okay, so I will see you first thing next Monday morning. All right.
All right. Thank you, doctor.
Okay, doctor.
Have a good weekend, guys.
Thank you, Doctor.
Thank you, doctor. Thank you,
Thank
doctor.
you, Doctor.
Thank you.
Wait, attendance. One second, attendance, Not go yet. Hello, wrong time. 10 o'clock. Okay. Okay. Link expire. Eleven 59. Update. Okay, copy link. Okay, so I have shared the attendance link in the chat box. There. Okay, so attendance link is in the chat box now. Make sure you do it before 12 o'clock noon time. Okay. All right, so I will see